Have you ever tried to refactor a legacy code which doesn't have any unit test? Have you ever tried to add a functionality to a legacy code? My name is Fahad Alavi, and in this video I am going to talk about how to do that without messing with the existing functionality. Let's start by taking a look at the code that we have and see what are the new requirements. We have an item class which has name, selling, and quality. Then we have a gilded rows class. In the gilded rows class, we have a constructor which accepts a list of items and update quality. In the update quality, we have a loop to iterate on all items, and based on the name, quality, and sometimes based on selling, we have some conditions, but conditions are not in order. I don't dare to touch them because I don't understand them, and refactoring a code like that is a nightmare. There is no unit test here. It is just one unit test which asserts 1 equal 1. Then I cannot be sure that after touching this application and this method, is my application going to work well again or not. And the goal for this refactoring is add another item to the list of the item that we have. Here, as I can see, we have edge, berry, backstage passes, and sulfurous hands of Ragnaros. I'm not sure what the hell are they, but we are going to add another item here to the list of the items and add some other calculation to it. First of all, we need to be sure that we have a test which covers 100% of this code, and after that we can start refactoring it. We need to have a fully covered code to be sure that after our change and refactoring it is still working and returning the same result. How can we do that? First of all, let's check if our test framework is working. Nice. And now it is time to think about how to do that. We have a kind of testing, a method which is called a snapshot testing. It is a way just to generate data and test data for an existing item. We are using a snapshot testing for many different things, for comparing JSONs, for writing unit tests, for our markups, XML, and sometimes for refactoring. Let's see how can we use that. The first thing we need to do is right-click on our project, add the NuGet, and the library that we are going to use is called Verify. Because I'm using XUnit as our test framework, I'm going to install verify.xunit. Let's install it. Nice. And let's go back to the test. First of all, I need to mark the class that I'm going to use the verify. I should type uses verify. Let's start with having just one item and update the quality and see what is the result. First, we need to have a list var items equal new list of items. I'm going to add to it items.add an item. For example, for name, I'm going to pass foo to it. And for selling, 0, and for quality, 0. And then I'm going to create an instance of gilded rows and pass the items to it. In the act, I'm going to just run the update method. Fine. And now how can I create this snapshot out of my test? The way that we are doing that is just calling the verify, verifier dot verify. What we are going to verify? We are going to verify items. By calling this method, verify framework is going to create a snapshot out of the test result that we have. As you can see here in the gilded rows kata, we are just passing a list of the items and we are changing the items inside the list here in the method. then the output is items. Just keep it in mind that we need to return this verifier, and it should be, the return type should be task. By running it, we will see that it is generating something for us. It is generating that name is foo and selling is -1. It is comparing something, a file with received with a file of verified. It is our unit test name, the first part, and the second part is our unit test name. It is the file name, unit test name, then received, and after that verified.txt. I'm just going to paste it here, save it, close the file. I'm going to go to the Solution Explorer, open the unit test 1 file, and I can see I have two files, received file and verify file. The received file is the file that verify framework is generating for us for the first time. And the verified is something that we verify and put our results there. The next time that I run this test, verify framework is going to remove the received file and just check and assert everything based on the value that we have inside the verified file. Nice, it is the way that it is taking the snapshot. Now if I run it, I will see that the test is passing. Now we need to generate data for all conditions that we have here, for all names and qualities and sellings that we have here, and we check here and generate a unit test coverage for 100% for this code. How I'm going to do that? There are so many ways to doing that, but I really like to have an array of names, sellings, and qualities, and have three nested fors to just create all possible combination of the values that my method accepts. How I'm going to do that? Like that, var names equal new name. What is the name? The first name that I have is foo. And then var sellings equal new. The first value that I have is 0. And var qualities equal new, an array of integer, and the first quality is 0. Then I'm going to have a for each, call it name out of names. Then another for each for sellings, and I'm going to call the variable selling, and another for each for qualities, and I'm going to call it quality. Then I'm going to generate an item and add it to my list like that. Name, selling, and quality. Let's run the test and see if there is any change in the output of our method. There is no change here. I need to have everything, all the names here in my name arrays. Let's see what names do we have. We have aged brie. I guess it's a kind of French cheese. We have backstage passes, and we have sulfurous. By the way, if you want to know a bit more about this kata, I highly recommend to check Gilded Rose Refactoring Kata by Emily Page. The way that I am following here for refactoring is by Emily Page, and it is the most effective way of refactoring a legacy code with a lot of nested if-else conditions. Just take a look at this one. We have this repository for almost all programming languages. You can enjoy it. Go back to code. I have all names, and now let's check the value of quality. I'm just clicking on quality. Visual Studio is going to make them all highlighted. I can see we are comparing it to 50. And what else? Just 50, 0, and 50. Fine. I'm going to have 0 and 50 for comparing. And what else? For cell in. For cell in, we have 0, we have 6 and 11. Let's have it here, 0, 6, and 11. Let's generate the snapshot file again by running it again, because we have a lot more test cases and test data here. It is going to fail the test and tells me that you have a lot more values. I'm going to copy everything from received and paste them into the verify, save it, and the next time that I run it, it will pass. I'm going to right click on the test and click on Analyze Code Coverage. Perfect. I can see that I have 100% covered lines. If I click on it, yes, in the gilded rows kata, I have 100% code covered. And if I just go back to the gilded rows kata and click on this icon for show code coverage, I can see that first let's check everything. You will see a result like that. You will see that everything is green. Why? Because all lines are covered. I really don't like to see my lines like that. Just this line here is enough. By just clicking on margin glyphs, it is going to show you that, and we really need it for this kata. We have a 100% unit test coverage for this code. It means that now we can be safe and start refactoring the code. But is it really correct? No, I guess it's not a correct statement, because as we discussed in one of my videos about the mutation testing, we need to be sure that if all the tests that I have is valid or not. If you haven't seen my video, I am going to put the link here. For mutation testing, I need to go to the PowerShell tab here. Go to my test project and run a striker. And the command is .NET striker. Let's see. Well, I have the result, and as I can see here, gilded rows, it killed the 42 mutations, but 6 survived. Let me see. Here it says that by changing this one to nothing, yeah, nothing happened, because we are checking if it is not HBRE and if it is not backstage passas, yes, correct. If it is not this one and this one, then it is sulfurous. I'm not going to touch this one for now. What is important to me is the values for selling. For selling, it says if I change it to not less than 11, and for 50, if we change it to less than equal 50. And things like that. Let me try to first address the sell in and quality one. Let's go back to code. Here in my unit test, we have some border values like 6, 11, 0, and here 0 and 50. Let's add one number before each of these border values and after that. For example, for 0, I'm going to add -1 and 1. For 6, I'm going to add 5 and 7. And for 11, I'm going to add 10 and 12. I'm going to do exactly the same thing for quality. For 0, I'm going to add -1 and 1. And for 50, I'm going to add 49 and 51. Let's run the test. Wow, as you can see, the number of the lines of code that we had for the previous verified snapshot testing was 112 lines, but now we have 1010 lines of code. I'm going to copy it, paste it, and run the test again. Now it is passing, and it is just 143 milliseconds, and it is an acceptable time for testing this huge number of the values. Let's go back to the development PowerShell, to developer PowerShell, and run the striker again. Well, now I can see that the striker for mutation score gives us 100%, and it is really nice. I'm going to check out the timeouts and ignored, and there is no survived mutation test here. Well, now I can be sure that I have 100% unit test coverage, and our code covered all the possible conditions for all blocks that we have here. How can we start refactoring now? First of all, let me go back here, go to our test, and run analyzer, code analyzer. Mark it, and I will see that here I have a code. Everything is covered. First of all, I really like to change it like that. Let me see. I'm going to extract everything and extract a method out of that. Yes, extract a method. Nice. This method, I'm going to call it update quality. Well, and here I'm just going to introduce another item just by selecting this item I and press control dot or control period. I'm going to introduce a local for item I. Just for this one, or in the all code, I'm going to do it for the whole code that I have. And as you can see, from now on, I can call it item. Let's run our unit test again and see if it is passing or not, and analyze code coverage. Please do not confuse these lines. They are for Git, and these lines are for code coverage. I have a private method here, and this private method is fully covered. Now we are going to use a technique which is called lift up the if conditions. Our goal in lift up if condition is that start with wrapping everything in an if else statement and try to remove not covered code. Let's see it together. You will understand it better. I'm going to create an if and an else. I'm going to copy the code block that I have and paste it inside the if and inside the else. And then remove my code. If I run the test again, it is passing because this condition is always true. Now it is time to decide which one of the conditions do I have here in this application I want to lift up. I'm going to create some if and else statement just based on the names that I have. Then I start by picking one of the names, copy it and paste it here. And I want to compare it just with equality, not with not equal, then change it to equality. And let's see what will happen. Then let's explain it again. I have if and else. Inside both if and else block, I have the same code. I chose one of the conditions that I have and lifted it up because I am going to have if in the first level just based on the names. And now I'm going to run the code coverage again and see what part of my application is not hit. My code coverage is 72%. It means that by this change, I have some codes that I cannot reach anymore. Let's open everything and see it. Fine. We have some parts of code which are not covered anymore. If it is not covered, it means that we are not using it anymore and we can get rid of them. How can we do that? My suggestion is that if you are using Visual Studio, start to doing that from the bottom of your code. If you are using Rider, you can start from top of your code because Visual Studio is not going to update this line when you remove something. As you can see, it is static and still here. You need to run the analyze coverage once more if you want to have this one updated. In Rider or maybe some other IDEs, it is not like that. For not facing any issue, I'm going to start from bottom of my code. This else statement is not touched. I'm going to remove it. As you can see here, there is no code, but it is still red. The Visual Studio team should fix it. I'm not sure why they're not thinking about that. This if statement, it is not reached anymore. And it is logical because here we are telling it if name is equal age debris, and here we are checking if name is not equal age debris. I'm going to remove it. We have an else here. When we don't have if, we don't need else as well. And let's go up. I will see this if statement is not called, and it is logical because here we have if name equal age debris and we are checking if name equal something else. I can get rid of this one. And here again, it is not covered. As you can see, I have one yellow color here which says that it is partially covered. I'm checking if name not equal age debris and not equal something else. And it is logical that I can never reach this block. I don't need this if, then I don't need the else as well. Let's run my code and see if it is passing or not. Yes, it is passing. It means that we haven't missed any functionality. The color that we see here, you can configure it easily just by going into Tools, Options, and then Font and Colors. Here we have something for coverage not touched, coverage partially touched, and coverage touched area. I changed it. The color that Visual Studio has by default is not really the color that I want and like. Let's run analyze code coverage and see if the code coverage is still 100%. No, it is not 100%. Let me check it. I like to have code coverage always here. Let's change my code to that. And let's see it here. Here it says that if name is not age debris, and we need to get rid of that one because we checked it here that name is age debris, and in the else we are checking if it is not age debris. Okay, by removing this one, It should work. Let's see the rest of the code. There is nothing here. Now it is time to check our if block. It is the last check that we have for this lift up condition. We have a name. Let's check if we are checking name here in the if or not. I can see I'm checking item name not equal sulfurous. Here I'm checking if name equal HB, and here I'm checking if it is not equal sulfurous. And of course, when name is HB, it is not equal sulfurous, then we don't need to have this if as well. It is one of the weak points of the Microsoft Code Coverage Analyzer that it doesn't check if the condition is always true or not. In some other IDEs like Rider and some other test frameworks, they can test it for you, and it is way better. Let's analyze the code coverage again. And now I have 100% unit test coverage, and I have an if block that I am sure that it is just checking edged brie. Now I'm going to just collapse this if and start cleaning up the else part. How I'm going to do that? By lifting up another condition. I'm going to create an if and then an else. I am going to copy everything, paste them once in if and again in else. And here I need to choose one condition to lift it up. Because we start lifting up the condition based on the name, I'm going to choose the second name, which is backstage passes. And I want it to be equal something. Nice. Let's run the analyze code coverage. And here it is just 71%. Let's see. Start from bottom of the code. Here this else never reached. I'm going to remove it. And here, as I can see, nothing here is reached. This else is useless. Let's go up. Here, this if a statement is not reached, I'm going to remove it. Then we don't need else as well. And let's go upper. This if a statement is not reached because we are telling if name equals something and then not equal something, it is logical. We don't need this if, and when we don't need the if, we don't need the else. Let's run the test again. We are running the test to be sure that we are not messing with the existing functionality of the function. And then we run the code analyzer to be sure that we get rid of all the not necessary code inside the project. The first part of the refactoring is to make the unit test coverage 100%. After that, we need to clean up the if clause and the if block. We need to check, are we just checking the name in the if, or inside the if block itself we are checking for other names as well. We don't need to have them, like the one that I'm going to remove here. And here we are checking if it is not edged brie. Of course it is not, because in this block name should be equal backstage passes. I'm going to just clean up the code a bit, run the test, and as you can see, it is passing. Just imagine removing each of these lines can be a nightmare if you don't have 100% unit test coverage, but we are just removing them with confidence. And let's run the code coverage analyzer to see the result. It is 100%, really nice. Now I am going to collapse this if and start refactoring the else part. How? By lifting up another condition. I'm going to have an if and have another else. I'm going to collapse all the code, cut them, paste them once inside the if and another time inside else. And it is time to choose to lift up something. I'm not going to lift up the backstage passage because I have it. I'm going to select this one, sulfurous. Let's copy it and paste it here. Make it equal. Run the test. It should, yeah, it is passing. And run the code coverage. It is 93%. Let's see how and why. This if statement is not covered. This one is not covered. This one is not covered. Okay, let's start from the bottom of the page again. Let's go up and find the first red line. This is the first red line that I have. Then it is not hit. I don't want this one. This if block is empty, then I don't want this one. This if block is empty again, then I need to get rid of that. I need to get rid of that, and I need to get rid of that. Wow. And what else? This if block is not covered, then we need to get rid of that one. Here, this if block is not covered. This if block has nothing, and this one has nothing. It means that we have no condition for sulfurous. And it was really funny because if I didn't have the 100% unit test coverage, which I generated using my snapshot testing, my verifier framework, I could never realize that for sulfurous we have no condition. And now we have an else. Okay, great. Let's check it. Let's check it. How many names do we have for our items? We have just edge brie, we have backstage passes, and we have sulfurs. And the rest is for other items that we don't have any specific name for them. Now it is time to run the code. Yeah, it is passing. Analyze the code coverage. It is 100%. It is time to refactor the code a bit. But before doing that, let me show you one funny thing. If I messed with code just by changing something here, for example, let me go to the edge tree and instead of +1, make it to +2 and run the code, run the test, I will see that the test will fail because the result that we generated for the previous one that we had, the previous code that we had, for example, on the production, and we knew that it is working fine, it is working for almost 2 years and there is no bug there, we are changing the result. By doing that, then we can be confident that our refactoring is not messing with the existing code that we have. Let's see what will happen if I not cover this one, or maybe in the refactoring if I remove this one mistakenly. Let me run the code again. And as you can see, we faced another error in the code and in the test. Then it is a proof that I can be 100% sure that I covered all the conditions and my code have 100% unit test coverage. And if I mess with the existing code, it will show it here, not on the production. Now it is time to change our code a bit. I'm going to change this if, else, and nested if to if, else if. I need to get rid of another close brackets, and I'm going to change this one to another else if and get rid of another close bracket. And I don't want the extra lines, and else. Now I have if name equal aged breed. Here we have some conditions for checking the quality and selling. Here we are checking if the name is equal something else. Backstage passes. Oh, inside this else if block, I shouldn't have any kind of checking for names anymore. Let's run the code. It is passing. Run the code analyzer. It should be 100% again. Yes. But here we have an if. In the if, we are checking if the name is equal backstage passes, and here again, if the name is equal backstage passes. This if statement is always true, then I don't need it. Let's remove it. As I told you, every time inside our if, we need to be sure that we have no other conditions which is checking the name. Now we can be sure about that. Okay, let's check for the sulfurous. We have no condition for sulfurous, and here in the else, it is checking that if name is not equal the backstage passes. Of course, because if it was checking that, it went to this block. I don't need this if here. Yes, and here I have name again. Name, if it is not equal sulfurous, of course, because if it was, it went to other block. And here another name, if it is not sulfurous, I don't need it. We are checking selling. We are checking if it is not HBRI, if it is not backstage passes. Of course, we don't need them. And here we are checking if it is not sulfurous again. And of course, we don't need this one as well. Let's run our code again. It is passing again, and run code analyzer. It is 100. It is 100% again. And I can say I cleaned up my code a bit based on the name of the items. And now I can start refactoring the code. Until now, we did nothing. We just cleaned up the code. We just lifted up the conditions based on the names. And we are checking the name in the first level of our conditions, not inside them anymore. And be careful, the reason that we are checking the else here is that inside my test, I have one dummy name here, which is called foo, and foo is the reason that I am checking this else part. We need to have it. Let's see and take a look at the code, how I can refactor this one first. Let's go back to the solution. In the solution, I can see that I have an item, and the items are checking here. I'm thinking it is better to have different items. Have a base item, have one item for HBRI, another item for backstage passes, and another for sulfurous. Let me just create them one by one. For HBRI, and it should inherit from item. Fine. And the other item is backstage passes. And it is inheriting from item again. And the last one is sulfurous. And it should inherit from item as well. Let's go back inside the item. I need to have one factory method here to generate the item for me. How I can use that? Just by creating a factory method like public static create item. I want to accept a string name and int selling and int quality. Oops. And then, for example, return new item. And for the new item, I really want to pass name and selling and quality to the constructor. It is what I really like. I'm going to generate a constructor here like that. And I'm going to pass name equal name, selling equals selling, and quality equal quality. Really nice. And I want to bring it up. Great. Oh, I forgot the return type, which is item here. It is the reason that we have an issue. Now we need to have an if statement or a switch statement here. How can I do that? Let's go back to the gilded rows. I'm going to press Control dot and if and convert it to switch. Really nice. Nothing happened yet. We have just a switch statement. Because I'm lazy, I'm going to copy this switch from here and put it inside the factory method. I just need the cases. I just need case, edgebree, case, backstage passes, sulfurous, and else, the default one. And this one should be name. Okay, then if name is edgebree, I really like to return edgebree. If the item is backstage passes, or if the item is sulfurous, I really like to return the exact object, and it should be backstage passes. We don't have any construction method here for them. Then how can we do that? And as you can see here, it is going to create the base for us as well in the constructor. Nice. Let's see how it handles that. It is going to create a constructor, passing the name, passing the selling, and passing the quality. Really nice. And here I need to have exactly the same thing, and here exactly the same thing. If I just check them, I can see in the backstage passes, I'm calling the base. And here I'm calling the base as well. If you want to have this window here, the nested window, just press Alt F12. And this return should be removed. When we are returning something, we don't need to have a break as well. The only thing left is for the default. For the default, I like to return the item. Because we don't have a named item, we should return the general item that we have here. Really nice, really nice. I just created one factory method here. Let me go back to the to the gilded rose class that I have. This quality is, update quality is nice, but we have different way for updating quality for the different item that we have. I really like to have it like this, quality, update quality for each item, update quality, something like that, because each item should know exactly the behavior and the way that updating the quality inside itself. It is not domain-driven design, but it is an approach of thinking that. Let me just create and generate this method. What I'm going to do here, I'm going to just move this one, this switch from here to here. Public, virtual, void. Why virtual? Because in all child classes and driven classes, I'm going to override this one. Here is the general item that we have. For this general item, we just want to have the else, because the else part is the part for general item. Okay, this item dot is a bit annoying. How can I get rid of that? By pressing Ctrl H for replacing it to nothing. Nice, and now it is working. Let's build up code and see. Yeah, we have an issue here, but we can address it later. It is inside our test. Let's go back to the item. In the item, we are checking the quality. We need to have exactly the same method in our driven classes. Here, we need to have public override update quality. I'm going to paste it here. It is for sulfurous. For sulfurous, we really do nothing. First, let me show you. It is the part that we have for sulfurous. And as you can see, we are not checking anything. Then let's have an empty block here. Let's check it for passes, backstage passes. Public override update quality. Paste it here. What we need to have here is just backstage passes. Great, we don't need the break, we don't need the case, and we need to get rid of the item. Fine. And here for the edge tree, public override update quality. I want to get rid of everything and have the just condition which is related to the edge tree, and get rid of items. I guess I have a running code. Let's see it. Here inside the gilded rose kata, I'm going to comment this one. If it works, let's comment it. In the gilded rose class, I'm commenting this one and calling the update quality. Let me run the code. I might have some issues. No, I don't. Yeah, I have one. In the item, it says that there is no construction method for no parameter. I need to use the construction method with the parameter here. Fine with me. I'm just going to change it to something like that. And the construction method that I have, the first one is name. Then it should be name, it should be selling, and it should be quality. Let me check if the order is correct. Yes, it is correct. And make it like that. Build the application again, and let's see. Yeah, successful. Now it is time to run the unit tests. Oh, we have some changes here. Let's see what it is for. As you can see, for the edge tree, we have some issues, and it is just related to the edge tree. And let's check it. No, for everything we have some issues. Let me check it and see why we do have it. It was unexpected. We are passing the name, selling, and the quality. And here we are updating the quality. And in the update quality, we are returning the item. Okay, get it. I get it. What's wrong with my code? Because here inside the unit test, I am still generating the item based on the construction, which means everything is an item here, but it should be item dot create item. And to be sure no one else can make this mistake, I'm going to change the access modifier of the constructor method to protected. Then no one can instantiate anything here for this item class. And now let's run it. And it is passing. As you saw, I did a mistake and it was not intentional. I shocked because I thought that it should pass, but now everything is passing. It means that my refactoring is done. If I close everything here, go back to the Solution Explorer and take a look at it, I can see that I have an HBRE which inherits from item backstage process, which checks its own conditions for the quality sulfurous and item. Really nice. I can understand it really well. We have one factory method here. And in the gilded rows one, let's get rid of this. Let's get rid of this commented method. I have a really clean class with single of responsibility. Okay, let's see. If I want to add another item here, I can easily inherit from item, something like, for example, HBRE, just pass the item here and call the parent constructor. And here we can update the quality for it. It was gilded rose kata. The last thing is about the verify framework. Let's go back to the GitHub page. This is the official repository for the verify. As you can see, it is one component and one NuGet with a lot of documentation, and verify itself supports verifying not only text, but also images, HTTP, mocking, everything. Just take a look at them. You can use it for almost everything. I use verify for various of reasons, for refactoring, for writing unit tests, for more markups. If I generate a component and I want to see if the generated HTML is exactly what I wanted, I'm using that. In this video, I'm not going to explain verify more than this one. We just needed to use verify to generate a test data for us to do the refactoring. If you like to know a bit more about verify, how to use it and what scenarios can you cover, just let me know in the comments. It was all the content that I prepared for today's session. If you like it, do not forget to subscribe to the channel and hit the like button. And if you click on the bell, you will be notified the next time that I upload a video for you. See you next time with another interesting topic about testing, .NET, or maybe something else.